Okay. Okay, Cap, welcome to the second half. Again, in the first half, we talked about what's required for your project presentation, a little bit about this. So today's lecture. So going this, right? Now, so all you have been shown is about whatever. Okay. So in other words, we are talking about the other 20% of data of machine learning used in data. Now, don't take my, again, this is sort of like my 80-20% rule kind of thing, right? If you work for a project that is strictly about text, then it will be 100%. It won't be 20% for you, okay? So this is, let me put that in double quote. The other 20%. Okay. So in that 20%, we're going to talk about this thing. We talk about RNN, okay? In this case, we don't talk about classical RNN. Classical RNN only has this kind of thingy, right? One shot. Modern RNN is more fancy. It looks a little bit like that, okay? It sort of like keeps the past memory, but it can also decide to forget about it or add to it or something like that. And the secret is here. In machine learning class, you can, everything here makes sense. I can actually, spend another 20 minutes talking about it, but we have other interesting things to talk about. Okay. Now, what is the most important thing that has happened in the last 15 years, 10 years? Yeah, literally 10 years, exactly. What's the most important thing? The most important. Let me put this way. This thing here, oops, RNN, multi-layer perceptron, all this were available 20, 30 years ago. Okay. Maybe not LSTM, but certainly earlier RNN. But this thing, CNN, is the most important thing that happened. CNN. What does CNN stand for? Convolutional neural network. Okay, so this is whenever your, we say input is an image, you will likely you will use some variation of this. Okay, you use some variation of this. Okay, so you guys remember last class I mentioned something, right? Remember last class, pre-processing, and then raw data, get to the pre-processing, get to a multi-layer perceptron, okay, remember that? We talk about pre-processing, right? We talk about pre-processing. Okay. Now you can think of, if you have image data, in other words, your data is numerical. but not sensible like client's salary or whatever. Okay? Why is it a numerical? Why is it numerical? Because, first of all, it's numerical because we have this thing called RGB. Yeah, RGB. Okay, what does RGB look like? Anybody? Blue. What's blue? Anybody? That's it. Blue is oops. Right? So basically, this is RGB red, green, and blue. So if I want blue, this is my blue. If I want red, this is my red. Okay? If I want red and blue, I get my magenta, right? If I want it darker, make it darker, right? If I want white, if I want black, that's my black. So, in other words, first of all, digital is everywhere. Okay? Digital image data is a rectangle array of 3 numbers, RGB. That's it. So it is number. It is number. Okay? Okay. So what I want to do here is likewise, so digital image processing NLP is cat. I want to do this. This is what I want to do. Okay? This is a cat. Now this is a dog. Okay? So the pre-processing and NLP. So what's another word I use for pre-processing? I use the word filter, right? Now, when I was at Imperial College, I was doing financial data, but most of my colleagues, my Ph.D. Students, friends, they were doing visual image recognition. The difference is back then, these things are chosen. Okay, so think of it this way. So stage 1, work with specified pre-processing. So now I'm not going to use the word pre-processing. I'm going to call it the word image filter. Now, what does image filter look like? Okay. Well, let me do this. Okay. So in Mathematica, if you got your camera hooked up, this is a current image. Whoops. For some reason, current image. Let's save. Okay, new document. Now this would be embarrassing. I think I turned on, oh, my bad. Let me turn off the camera here. I think because I'm using the camera maybe. Let me turn on this camera and see if this works. Yeah, see if this works. Okay, it works. Okay. Okay. Now let's make this dynamic. Okay. So you guys, can you guys see me now? Right? Okay. So this is within Mathematica. Now, what happened is to pre-process every image here, I can do what's called image convolve. Okay. Now, image convolve comes with a pre-specified filter. Okay, so let me define my filter. Okay, my image filter. Let's call it vertical detect is equal to. I prepared this ahead of time, so let me just copy that. Okay. Yeah, so that's my vertical image filter. Now I'm going to image convolve my own face with this. And I can make this dynamic as before. See? So it's actually detecting the vertical light. I can do this and you won't see a thing, right? I can do this, you can see my hole. Yeah. So it's detecting vertical, okay? Now, based on this image filter, okay, you can do anything. That's the state of the art when I was a student. When I was a student, the state of the art was you choose image filter to detect things. So there's one for, you know, so you can do, if you go to F1, there'll be other examples to play with, you know, all kind of filters. Okay. Now you can do like edge detect, in which case it's similar to that, but it's used so often that you don't need to use this. Yeah. Right? Okay, so it's that kind of filtering. Okay, it's that kind of filtering that we're talking about. Okay, it's that kind of filtering. The problem with the state of the art back then was it's pre-specified image filter. Nobody. Okay, the only trick is here, stage 2, which is where now. Let's say back then, when I was your age, or maybe a little bit older. Nowadays, the image filter is called convolution. Because the operation that it does, what basically it does is this. We have this matrix. Okay, let's go back to image convolve. Okay. Let's make it a little bit more clear. Matrix form. There, that's my matrix. Okay, let's add that. Okay, what it does is that for every pixel from the top left to the bottom right, you apply this scanning window of 3 by 3 pixel. So this is only for 3 pixel by 3 pixel, and you scan it, you scan it, you scan it, you scan it, and you multiply -1 to the top left of that little block, multiply by 0 the top, of that, multiply by 1 top right, multiply by -2 the middle left, multiply by 0 the middle, multiply by 2 the right middle, multiply by -1 the bottom left, multiply by 0 the bottom, and multiply by 1 the bottom right to every 3 by 3 pixel. You multiply that for all the picture, and then you show that picture. That's what you get. That's what you get. The problem is you have to choose which pixel to process. You want to get vertical. So these are well designed. This is like a library. You know, you have a whole library. So if you go to internet, you see something like library of convolution image filter. Whole bunch of them, okay? So it's like a whole bunch of them. Now, what's different? What's different with convolutional neural network? And this is really, you know, I could have kicked myself, or my friends could have kicked themselves. Nowadays, the matrix element convolution learn. That's it. That is it. That is the most important thing that has underlined all the breakthrough in AI technology in the past 10 years. Instead of using pre-specified convolution, you remember the neural network, right? It has all the weights. Well, the weights are just numbers that are chosen by example. In this case, instead of putting the number, you put in something like, you know, W11, U12, U13, and so on. And use gradient descent to shoot, to learn, to train. Yeah. Okay, that's it. That is the most important thing. Now, this has a historical root, by the way. This has historical, that's why I sent you the video earlier, because, and this is very important, because of this guy. So I'm still sharing the video, correct? Big data. Okay, that's you guys. Okay. So this, let me go. Let's show this picture. These two people, this guy is old now, but when he was young, this was in the 50s. And this guy is Wiesel, I think this is Hubert. I'm not sure who's who, okay? These two, what they did was they put Wiesel experiment. Okay, this is what they did, okay? What they did was they stick a cap, a real cap. This is in 1958, 1959. Stick the cap, stick in the electrode to the back of the visual cortex, right? And make sure the cap doesn't go anywhere. So maybe paralyze it temporarily. This is, you know, still humane. And show a different picture. Show a different picture, okay? What happened is this. The image here, they show like horizontal picture, they show like this picture, they show vertical picture, you know, maybe 45 degrees. So these are all the different picture. Let's go to picture. Okay, yeah, this one, right? So show this picture, show that picture, show this picture, show that picture. It turns out that the small, simple cell detects pattern. How does it do that? It acts like a convolution filter. So you can imagine there's a neuron here, okay, that takes a -1 in this area. There's a neuron that takes a +1 here, takes no value here. So this is kind of like the excitement. It's called receptive field. So one neuron, one cap neuron has the input that has this potential. So this looks at the scan all the area, right? And then if it's vertical, it lights up. If it's horizontal, it stays silent. Now, obviously, with visual recognition, you want it to be what's called translation invariant. So the vertical can be here and there, here and everywhere. So you have to scan many of them. So this guy found out that the way CAT's neuron work is there are simple neuron that maybe detects pattern, vertical, horizontal, and there are complex neuron that pulls a bunch of these together. So it detects vertical line wherever disappear. Okay, if there's a vertical line on the top left corner of the picture, it would find it because it pulls together. Okay, so I'll give you it's sometimes it's nice to use historical for yeah, Hubel, and whereas simple cell corresponds strongly to whereas a certain phases, complex cell response are insensitive to translation of stimulus. And this is from Hubel and Philbert, 1962. Based on this, and this is, you know, a whole bunch of things. Based on this, okay, based on this guy, so this guy was a biologist, not artificial intelligence researcher. So basically what happened is, you can say that okay, you can say that Hubel and Wiesel, 1960, let's say 60, discover that cats visual receptive field responds to pattern, vertical line, in a translation invariant way. Here, anywhere, picture. Okay, so in other words, detecting pattern, that's like a convolutional filter. Complex is like pooling a whole bunch of convolutional new together. So the innovation was Fukushima. I think it's 79. This one is 58. Yeah. Came up with neural network that mimics simple and complex. Call it cognition. Yeah. What's the problem? Oh, theoretically. But computationally, no can do. So this is 1980s. So what happened? So this is 1980. So let's go to my paper stack. My reading. So this is my seminal paper. This is Fukushima. Fukushima. Okay, so this is basically 1920 picture. Okay, so this is this guy. Okay, so this was really done in the 80s. How come you don't have iPhone in the 1980s? Because you can't compute. You have to wait for one more guy. And wait for this guy. This guy in 2012 or 2010. Okay, in 2010. Used similar to this, but he used game card. You know what a game card is? Game card, CPU. Okay, graphic cards. This guy use game card. Okay, this guy. So these three guys. By the way, this is more like the teacher. This is more like student because this one is been a while. So use idea developed like this from Fukushima in the 80s. Okay, that resemble the cat research. Okay, so until you have to wait until, where's the picture? Okay, so you have to wait until, oops, this guy. 2012, 11, I think it's 2011. Use NVIDIA game card. Now I'm trying to see, let's just for fun, let's find what the game card is. NVIDIA. GTX 580. Now, this is ancient by today's standard. I don't know if you guys play any video games, but this is, you know, you wouldn't be able to play any games right now with this because it's so old. But use this thing to solve image recognition. Yeah. Then you start to visualize. Okay. Blah, blah, blah. 2 years later, to image. Long story short. Long. So 2 years later, that's what. Okay, so that's basically how this works. Now, if you like to see the inspiration things, how this works, see. Okay. Okay. Now, I only have like 20 minutes to cover this thing, and this is bigger than anything else that came before it. Okay. So this thing is called GNN. Okay. Notice how everything can be represented by an network. Right? So social network, financial network. Okay, what else? What kind of network? What else can you have? Well, communication network or digital. Okay, what else? All kinds of stuff. Everything is a network, right? Okay, so how do you analyze network? How do you analyze network? Okay, analyze. Well, don't mean to brag, but maybe I should brag. Okay, there it is. In 2010, this is me. In 2010, I made this network. This before social network. So I should put down the word something like before social network was a thing. Financial contagion was the few years was the problem facing economy. You guys don't remember this, but this is financial crisis 2006 to 8. Okay? So this is mean small bank. Small bank could collapse and pull down big banks with them. Yeah, it's not banks, but small financial institution could collapse and pull down. Due to network sensitivity to sale. Okay? In other words, banks were lending to each other. So it's a network of financial connection. But the big banks can be pulled down by small banks. So have to figure out the network leverage. Each bank, no matter how small. Okay? Excellent. And this becomes a concept of systemic importance. Okay? So, Bank of Thailand, even though not affected by 2006. Wanted to know. So I model financial network as a graph and propose now. Then, a few years later, then Facebook made social network a thing. Marketing wanted to capitalize on that, so start to do centrality as marketing. Okay? So, long story short, it used to be banks that matter were too big to fail because they were big banks. Now, banks can be small. So, it used to be, okay, so from too big to fail banks now need to focus on too systemic important to fail. even small. That's it. That's the but. Okay. Now this is the centrality analysis was due to I didn't come up with it. I based on what year was that? Let's find out. I don't remember the year, so let's go to what year? 1987. Now, my focus, I didn't care about social network, nobody did. My focus was that which bank is so central to the network, it's like a key man, that if this bank fails, other banks will fall. Flip this problem around. You can say that if I want to target a group of teenagers to sell products, which teenager is central to the network of teenagers? Okay, so now becomes something like which teenager is, okay, the quote unquote systemic influencer among yes. Okay, so if you want to sell something, then make this guy girl brand ambassador. Okay. In the old day, brand ambassador were like movie star, but now no. You just can be, you know, YouTube, some kind of YouTube top influencer. Now, but it's a lot easier now because you can just add number of prescribers. But back then, you have to identify them. So that's it. That's called network analysis. So the first, so just like this has two stages. So back then was back then. Okay. So now, next stage. Next. How about combining network analysis with machine learning? In other words, neural network. Now, because technically, by the way, technically, when network is called graph in mathematics. Okay, so when you combine network analysis to neural network, you get graph neural. Okay? So now you want to learn, predict, etc. You have doing with the NLP on input that themselves are part of social network. So back to data set. If the data set has all these attributes of the clients, and you have client number 1, client number 2, client number 3, client number 4. You used to process that information independently. Now, put that on a neuron, on a social network structure, then it becomes important. So in other words, so you used to say predict buying decision based on, let's come up with Jane's numerical vector attribute. Now, use numerical vector attribute from Jane's friends. Okay, or maybe it's false. You know, maybe information that people, Jane doesn't like to buy the same thing, whatever. Okay. So this is where graph neural network comes in. Okay, this is where graph neural network comes in. Now, some of this, you know, I write this down, you can ignore it. Some of the YouTube comments are not strictly speaking correct. Okay, if I were to play them in class, I can certainly do that. But when it gets to certain minutes, you know, say here, you know, I have to sort of like make clarification. It's not necessarily correction. It's not like they're wrong, but some of the comments are not precise. Could be a little bit misleading. So I make these notes, but you know, for all practical purpose, when you watch them, just ignore this. But I make this note because I know that, strictly speaking, certain things are not 100% kosher. Okay, but do watch them because YouTubes are full of wonderful animations. Okay, so again, so this is so now once I have this kind of a visual, okay, turns into information, it becomes a vector. So now picture into a vector. So basically all this means that everything now is an input. Okay. So all together, image, word, relationship, right? And also, you know, something like songs, etc., can be vectorized or embedded as numerical vectors. After which you can then do all sorts of machine learning tasks around. And that's where we are today. Okay, that's where we are today. So that's why all this V for big data, variety V, right? Can be handled now. Can be handled. So now you have what's beyond all this? Well, these guys, RNN, in particular, LSTM, and natural language processing, convolutional neural network, and graph neural network. Now, graph neural network. So this thing, where's the word? And graph neural network, GNN. Now, in the most general form of neural network machine learning. There is a framework, geometric deep learning, that kind of subsume everything. You know, all the embedding, all the CNN under same umbrella. Yeah, but a little bit too advanced. Even too advanced for me. Okay. But this is the future. In the future, you will hear this word more. Okay. CNN, you will hear less. Okay. This will just become garden variety. So that's where the technology is. Okay, that's where technology. So today, you know, you've seen, and again, this video here. If you go to, I think, let me just show you just one example of a good video. Graph neural network. Yeah, this here is a very good playlist, but let me just go with this guy. Okay. Grammarly, I don't care about Grammarly. Okay, okay, let me go to the picture. Okay. Now, this is the picture I want to use. This is Jane. This is a vector corresponding to Jane. So it's actually an embedding, another layer of embedding. But this is Jane. But instead of feeding Jane's information, feeds Jane's friends' information. So maybe James and Dave. And this is based on what's called adjacency matrix, who's friend with whom. Now, this is very straightforward. This is very straightforward. This is saying that in order to predict Jane's behavior, I ask who's Jane's friend. James? Okay, let's add his information too. But what's more critical is this kind of, should we look at James, becomes what's called attention mechanism. So I should pay attention to Jane's friend according to some calculation. So instead of just looking from yes or no, is James James' friend? If James is James' friend, then just add James' vector to it. That's too easy. That's too straightforward. You have what's called attention mechanism, where you actually learn the relationship. Okay, so it's a little bit like when I move from pre-specified convolutional filter to convolutional neural network. There, I specify the convolution and I use it. Here, you specify the adjacency matrix, who's friend with whom, and use it. No, let's make this a learnable set. So watch this video. Go to the part where there. So this attention coefficient is now learned. Just like the convolutional coefficient, okay? I used to have this fixed convolutional filter. Now I make this a learnable parameters. Likewise, the graph attention network make this connection a learnable parameter, okay? And, you know, just to tie everything back together, even a sentence is a graph, okay? Instead of saying you and your friends, you can say word and the previous word. So these are actually items in the graph. This is network of words. This is actually a network of words. So if everything in life can be viewed as a network, and every time you want to do learning or model or any kind of artificial intelligence on neural net on graph structure, you need GNN. You can imagine why in the next 5 to 10 years, graph neural network will dominate everything in the next 5 to 10 years. Okay. So, in fact, I have 2 new projects that I'm going to do. One is from a private company. One is from Capital Asset Market Research Foundation. they're actually granting me and my team research fund to actually use graph neural network. Okay, so next year, I'm going to be spending 80% of my life on graph neural network. I can tell you that. I'm pretty sure. In my consultancy and my project research, both. Okay, so graph neural network is pretty much going to be the end all. Now, before I go to comments on students, I just want to add a little something here. This is YouTube about how to read research paper, how to deal with GitHub, how to produce a nice academic paper. This is just something I want to add. Okay, so that's it. So let me finish here in terms of the lecture part. And I don't know if you need this. You probably don't need this. Okay. Right. So let's stop share. Let's go. We have 10 or 12 students. So let's shift gear and go to again, while everybody is good attention, you will have to grade your friends. So you have to pay attention to your friend's presentation. Okay. So you have to do that. Not now, but starting from next week. Okay, from next week. Okay. Okay. Natkat, who's up? Okay.
Oh, sorry. Okay. Next is Sunacha.
Hold on. Okay, so Sunacha, let me also turn on my scoring part. So I will be distributing the scoring template for everyone before next class. Okay, Sunacha, where are you?
อาจารย์คะ Sunacha is already present ค่ะ last week.
Oh, okay.
Oh, sorry. So next is the next is Jenjira ครับ
Jenjira, okay.
Hello.
Hello, Kap.
Okay, I'm gonna share the screen.
Yes, screen, Kap. Okay, Kap. It's all yours.
Okay, my data is the renewable versus nuclear energy generation. Since
good. That's good.
They provided 4 data, but I use this the electronic production by sources. They divide the source of electricity production to coal, solar, wind, oil, nuclear in percentage. 3 countries since 2000 to 2020.
Okay, very good.
So for the objective of my project is to evaluate Thailand's energy production compared with other countries and like classify the countries to their energy development from maybe they are developing toward nuclear energy or they are developing toward renewable energy. So firstly I did some cleaning and defined some for my convenience to data because the data has too many lines, too many rows and columns. So I defined some function to extract the data only from Thailand or only from Thailand in specific years. And okay, this is the electricity production in Thailand. And here is the green ones are the renewable energy, blue are fossil fuel, and red is nuclear. Then okay, I noted to myself that there where I can write some insights, and then I group the energy source like hydro, solar, wind, and other renewables are renewable, and I group fossil fuel, nuclear, and then I combine them into one graph. so I can see how it's going. Okay, and this Thailand, and I pick another one country that I have heard before that it uses mostly nuclear energy, and I found it's France. France use mostly nuclear energy and use fossil fuel in the least one. So then I want to find some trends. What are the countries are going toward by using linear model fit? So this is the plot of each year, and I use linear model fit to find the slope or the progression of their development. And I'm gonna use this data to so these are the categories I defined. So if the country use renewable energy and nuclear energy more than fossil fuel, I define these countries are the developed countries, and the developed countries can be classified into subcategories that developed countries toward renewable energy solely, developed country towards nuclear energy solely, and other developed country towards renewable.
Okay. Just in terms of vocabulary, normally when you talk about developed or not developed, the metric they use would be like standard of living or GDP per capita. So I think what you mean is countries that are sort of like adopting, right?
Yes. So classifying the development in energy perspective.
Yeah. So I have to. So maybe just choose a different word or something that's a bit more clear, because people would just say, "Oh, this is how you." Normally, so development in terms of global economics, it's a well specified word. So if you use that word already, if you use a word, people will misunderstand what you're trying to do. That's all.
Okay. Okay, and so how can I classify this? I will use so firstly I have to find the two variables, because many data have many variables, and I want to compact them in only two variables, where X is the trend of using renewable minus of using nuclear. So I can know that they are moving toward renewable or nuclear. And the Y is the rate of fossil fuel reduction. And when the countries are plotted, then I can use maybe decision tree. So if X equals Y or minus X equals Y is one category and one another. So my are still at point, and these are the thing I'm not done yet, and I don't know whether should I include it. It is the time series prediction. So maybe it can be used to predict how Thailand or any country will use the energy in the future, and predicted by the past progression. So
let me just confirm, when you do regression, you're using different countries, right, as your database. Are you fitting the time series of one country, or are you using factors of country to predict?
So just use the data of particular country to predict that particular country.
Okay, to me, I think that's going to be a little bit difficult, because what it is that you're predicting the adoption, right? So you would hope that it increases, but there isn't much dynamics, you know, to use the time series of one country. That means there's like a continuous dynamics. Say you're predicting GDP data or something, whereas this is something that's more structural. So I would imagine the factor would not be auto-regressive. In other words, you can't just look at the time series of adoption rate to predict adoption, because that can only say that, you know, the future probably is higher than the present. Okay, you should use, it should be something else about that country, like, you know, the level of energy dependence or GDP per capita or current rate of fossil fuel consumption or import of oil. Like if somebody can import a lot of oil, will in the future will likely import less. I would imagine to do regression, you should do more like a factor, right? In other words, predict adoption based on characteristic of a country, in which case every country is your data set. If you just take Thailand and just look at this graph and you're just trying to fit a line, I don't think that's going to give you that much insight, right? Now, you may not be able to build a prediction model, but this kind of clustering of different groups might make sense. So I would not restrict myself to just Thailand. I would imagine that this is the perfect situation where you're looking at peers. Okay, so go take a look at the example that I sent to you about COVID data, where you look at cross country. I think something like that would be a good template. In other words, you're just looking at Thailand relative to other country, right? Maybe there's some interactive graph using manipulate that allows you to say, okay, what if I don't want to look at Thailand? I want to look at Cambodia. I would want to look at Laos. I want to look at Thailand versus China, China versus Taiwan, or whatever, right? So there's a lot of interactivity you can build into. Okay. Okay. I think it, you know, between visualization and factor regression, you can do something very interesting. But just to take, you know, Thailand's adoption rate and you know, project it, I don't think that makes too much sense. Okay. I really don't. Okay. Okay. Good. Next up. By the way, if you make all your graph available, okay, not only do you make an application, you can also make it like cloud deploy. You know how to do that, right?
So I'm thinking about do some maps and color, like
yeah.
If that country use mostly that energy, it will have darker red.
Exactly. Yes. Do a lot of visualization, and then you can make it available sort of like offline. Okay, let me share my screen real quick, just to do something. Okay, for your project, and this is common to everyone. Okay, where are you? Okay. Okay, Cup. Now, let me share with this. This is just an example. It just happened to be something that I did for Batsai. Oh, I haven't shared, have I? Sorry. Okay, so if you, oops, let me share screen. Okay, share screen. Let's share this screen. Okay. Okay, so yeah, this just happened to be something I made up. This is to show prerequisite. Like if you want to take data analytics, you have to take or machine learning and so on. This is for applied digital intelligence track, right? Machine learning optimization. Before you learn optimization, you have to learn linear algebra, that sort of thing. Okay. So anyway, this is an interactive visualization. No biggie. Now, what you can do, and imagine all of you will have something like this, right? You can do two things, by the way. One is to wrap the whole thing under cloud deploy. Okay, so whatever it is, you just put it in under cloud deploy, this thing, whatever you want to do, okay? Plot a graph or manipulate something, right? And then you make your permission public. once you did this, it's going to generate this cloud deployment. And this cloud deployment then means that you can actually access it from somewhere else. So you can literally do this and send this to your friend in line, and your friend doesn't have to have or your mom doesn't have to have a Mathematica and can play with this. So whatever application that you come up with in your project, you can cloud deploy. Now, obviously, because you're using student student license, and you don't have a permanent cloud space, I think this is going to it's going to be made available for like a year or something. Afterward, I think it might get deleted. Okay, so that's one thing you can do, cloud deploy. Another thing you can do is this, animation. Okay, so I make this table. Basically, I just add different setting for this variable, right? And then I wrap it and then export it as a GIF. Okay, so now instead of having an application that just sort of like sits there, I can have an animation that looks like this. See, it just kind of like self-animates. Okay, so there's two things you can do with your projects apps, right? You can demonstrate it by cloud deploying it. You can also play with it with animation. Just make basically a table of this picture, and then export this table as GIF, and that will become an animation file. Okay, so this will just play forever, whatever. Okay, so you can see that you start with calculus, probability, and if you want to take, so this is like a sequence of course. I'm going to make this available for applied digital intelligence students later, so that they know that, yeah, before you take this, you need this. Before machine learning 2, you need optimization and so forth. Okay, so likewise, you can do all that with your thing. Okay, so those are the two mechanisms that I encourage you to use. One is cloud deploy. The other one is animation. So you can animate and manipulate screen and then save it as a GIF file. So now it's just a GIF file. I can play it whenever I like. Okay. Okay. Next student, please. So you are Jane Jira. Yes. Yes. What is your? Well, let me stop sharing. Sorry. Stop share. What is your student number again?
635-861-7156.
Okay, who's next? Who's next?
Okay,ครับ. The next is ธีรุธครับ.
นัดส่งไอ order list มาอีกทีดิ
Okay.
ส่งมาในไลน์ที่
You can go to
ส่งมาในไลน์ที่นะไม่ต้องส่งมา
the private. I already sent. You can get
โอเค
it.
ก็โอเคครับได้โอเค so เจนจิรา fine ธีรุธครับธีรุธอยู่ครับฮัลโหล
Hello.
Okay.
So I'm doing tourism.
Make it a little bit bigger ครับ I can't see.
So I'm doing tourism from Thailand, from each country, from 2020 to 2020.
What is this number?
Amount of people from each country coming to Thailand.
นัดได้ยินไหมพี่ไม่ค่อยได้ยินไมค์เขาว่า
Hello.
Hello.
Can you speak a little bit louder?
One minute.
some kind of number, some kind of count. China.
โอเคได้ยินไหมครับ
ได้ยินครับ Okay, that's much better.
โอเคครับso this is the number of tourism from each country
Tourist. Okay, gotcha.
to Thailand. So there's a gap between March until October because of COVID lockdown. Yeah. So the main purpose of the data is so that businesses, small businesses, can have the data so that they know which country are coming into Thailand.
Okay.
And they can compare it from the later data with the data right now and how much they could expect to increase.
Mm-hmm.
Yes. And
So what do you see this as? Some kind of, well, first of all, let me just ask you a very quick multiple choice. Do you see this as a mostly data visualization? Do you see this as a mostly unsupervised learning? Do you see this mostly as supervised learning?
Mostly as a supervised learning.
Okay, how?
Because they would need to keep on looking at the data and supervise the data for a period of time because the data could change pretty extensively.
But to make a supervised learning, you certainly need a lot of data to for example, what would be your X, what would be your Y? Your Y would be what? The number of tourists you expect from a particular country or what?
The Y would be the number of tourists expected, and the X would be the month and the month of each month in the year.
Okay. Now it's going to be a little bit hard from looking at this data. You can fit a line through it, but there's not a lot of information. This is kind of like the opposite of big data. This is a very small data kind of thing, right? So how can you make sure that you can predict? Basically, you only have like what 8 months? No, sorry, 1, 2, 3, 4, 5. You have 9 months of post-COVID data, and you know that pre-COVID data and post-COVID data are very different. How can you improve this? Where did you get this data source from?
The tourism and something of the government.
Okay, maybe you need something else besides country breakdown. Maybe you need some other demographic factors like age or whether or not they have been to Thailand already before, or you can look up things like COVID status of the visiting country. I think this is going to have very superficial analysis. You see what I mean? It's what can you do with this? There's really not much. So I think I can give you advice on what to do, but if you start with very barren data asset, it's really there isn't much you can do here. Okay, you can maybe compare that the pre-COVID versus post-COVID, and then you can say that different countries are ranked in terms of the percentage drop, right? Or maybe like China can be the largest group now, but in terms of percentage drop, it's dropped more than any other country. So perhaps you can target other countries that were not big market, were not big tourist market, but did not suffer as much of a drop, right? So maybe instead of China, you can say that well, we didn't have a lot of Hong Kong people, but the drop off is not as significant. But beyond something like that kind of comparison, there isn't much you can do unless you add factor that would help in prediction. So I think this project needs a lot of thinking. as is, it looks fairly weak. So you have to think of more. Maybe add more data source or something. Okay. Okay, Pat. Okay. Okay. Next.
Okay.
สวัสดีค่ะ
next case เวลา
Mira.
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 Yes ค่ะ
Okay.
Okay, let me share screen. Do you see my data?
Good. Okay.
Okay.
Where are we? So this is also a sort of like a country kind of profiling. Good.
Yeah, it is a
Suicide,
suicide rate
wow.
overview between
Yeah.
1985 to 2016.
Yeah.
Yeah,
Good.
and this is the data.
Okay, breakdown by population. So it gives a within country breakdown as well, right? Like
Yes.
young people versus old people and so forth.
Yes.
Good.
It will have like different gender and ages.
Okay. Now you know this concept about when variables are dependent on one another, that you need to use ratio. For example, if I look at a country, right? If I look at a country and I say that most people who kill themselves are young people. Young people will kill themselves more than old people, right? On its own, that seems to say something until we realize that this country just has a lot of young people, right?
Oh.
So in other words, relative to their demographic profile, it may turn out that even though this country has a lot of young people suicide, it turns out that it's the old people who are more at risk, right? So you have to be extremely careful in terms of which data represent meaning in itself, which data has to be divided by which column, basically. So this is something that you have to read the original source of the data to see the data description and make an informed decision about the variable you will be playing with, right? It may be something like percentage of suicide per bracket. Okay, so a lot of that, chances are you won't be able to do raw analysis on this variable. Chances are you probably have to make this column divide by that column, or take an average of this and that and so forth. So think about this carefully. Yeah. Now, what would you like to do about this? What would you get to the point where you actually try to predict risk factor, or what takes into account? So yeah.
I want to compare that the economic, like GDP rate.
Yeah.
Is it affect the suicide rate, like affect on which ages or which gender the most?
Okay. Now, again, if you go back to last class, you remember about this variable importance, right? If you do like a regression, standardized regression, then you can look at coefficient. But if you use chat value, it can actually tell you whether or not this factor is important in a certain way. So that's also interesting. Yeah, this is a sort of exercise that I think is very sensible. You're doing a cross-country comparison. Again, every country is a data point. So this is the sort of thing that I think would make sense. And this goes back to the first student. I think Kenjira was. That instead of looking at Thailand, let's look at cross-country, and let's just make every country a data point, or make every country, each year of every country a data point. Okay, so you can control for year, you can control for country, and so forth. So good, this is good. So you're making the data set, okay, and you know how to access different. Okay, you're trying to make the. I think GDP. To single out GDP as a factor for suicide, I think that would probably not give you much. Okay, so instead of having a hypothesis, does GDP lead to higher or lower suicide? Maybe you can ask the opposite. Okay, when you ask hypothesis question, you're working like statistician. Okay, hypothesis, statisticians do that. Does GDP influence suicide? Now, if you work like data scientists, chances are you would do something else. You would do the opposite. You would say, hey, let's make a suicide prediction model and see whether or not GDP matters. You see what I mean? It's a different kind of thinking, right? It's different kind of thinking. So economists, econometricians, statisticians, they tend to have in mind that suicide is a function of, say, GDP. And so do statistical tests, does GDP matter? Whereas for data analytics or data scientists, it tends to be a more general kind of like, well, let's find out what matters when it comes to predicting suicide. And then see, oh, okay, well, GDP matters a lot, or GDP doesn't matter at all, or something like that. You see what I mean? I'm trying to get the thinking to more approximate how a data scientist would approach the problem. What kind of prediction model or technique you intend to use?
I intend to use like the graph to see the relationships between it. First, I select only Thailand as Genjira does, and then the gender and the suicide number in each year, like for total and each gender as well. And I try to plot the GDP rate in Thailand.
Another comment I like to make again is that think of data as something that you had to pay for, right? You have to pay for, you have to, pay a lot of money to get this data set. Now, if you got all this data set, has all the country, has all the factors, and then you throw everything else out and say, okay, well, just look at Thailand and let's look at GDP. This is not really the ethos that I'm trying to set as an example. If your objective is to look at suicide rate, and if all you got is GDP, then yes, you have to see whether or not GDP matters in suicide. But here you're talking about the data set that has all kind of variable, right? Go up a little bit to the original. What else have you got? Yeah, to the field, the list of field, right? Age, affluent, yeah, population, yeah, suicide, country, year. Is this all it? Yeah, you have this thing like generation, boomer or something, yeah. So maybe boomers are more or less likely to whatever. So try to add more, try to not just throw everything out. Okay, what about sex? What about age? Right? Right?
Huh.
So again, think of data as something precious, right? Big data, that doesn't mean that you have a lot of data, so let's throw them all out and just look at something you care. No, you shouldn't just care about one thing, right? You should care about everything whatsoever that would allow you to predict suicide rate, let's say. Okay, so this is the wrong way of economizing the problem, right? Don't start out with 100 variables and say, I'm just going to look at one. Now maybe you can't look at 500 of them, so you can look at 100, but that's just because of the limitation. But this is like you voluntarily throwing away your data. This does not make sense. I mean, think of data as something that you have to pay for. Something that, I pay a lot of money for this data set so I can get insights about Y. So I pay for a lot of money for X. Once you got, 5, 6, 8, 10 different X, and you say, okay, I don't care about all of them. I'm just going to look at one column. That's wasteful. Okay. So think of how you use your data. Think of how you would approach this in life, and think about it. If everybody has the same access to this data set, and they don't throw away the variables, but you do, who's going to come up with a better explanation? Right? It's like you're handicapping yourself. You're handicapping yourself. Okay, you a chef, you got 100 ingredients. You say, I'm just going to use egg. I'm going to make everything out of egg. Okay, that's not so good. Okay, okay, ครับ
Thank you ค่ะ
ค่ะ this is Mira, right? Okay, next.
Okay, the next is ปริยาครับ
ปิริยา
อาจารย์คะ can you let Radha go first ค่ะ 'cause
Okay,
she needs
Radha. Fine.
Thank you. I have to leave really soon. Can you see her? So my data is the data from online stores on what they sell from 2010 to 2011, and data on the stores from like customers from different countries, from UK, France.
Oh, good.
Yeah, and also other countries. And then there's data on the description on what they buy, the items, the quantity they buy, the invoice date, and also the unit price. And each customers also have their own IDs. Yeah, so what I did, I first like imported the data in, and then I started it off by grouping the customers to see how many transactions each of them made. So then like I plan on like afterwards I can, try to see which customers is valuable and also find their frequency in buying and recency since they're last the items.
Okay.
Yeah, and this one I also try like count on which customers and then sort them. And I'm also planning to use the date to see as well if there's like the prime time where their items are sell the most, because the stores they mostly sell like gift products, and in the description from Kaggle they say that it's like all occasion products. So I'm figuring out to try to find like if there's actually like something seasonal for this data as well.
Gotcha. That's good.
Yeah, and for the description of each item, I will also try to see if I can do some market basket analysis, because
Okay, good.
yeah,
good.
because I have all the information on like what they buy, like what's the price, and also the quantity they buy.
Okay.
Yeah,
So you can see how this polka dot basket would tend to pair well with something else, and all that, right?
Yeah.
Now with basket analysis, you know that there are basically four styles to it, right? It's sort of like analyzing which groups of product appear together, right? So probability of milk and bread, and the other one is sort of like sequential in the sense that if you knew that this guy bought milk, is he likely to buy bread, right? And then you can have both of those versions across time. So you have basket that's earlier in the week or in the month, and then later basket and so forth. So yeah, explore that. Good. Okay, Kap. This is good. Are you also trying to do general machine learning prediction of good customer? Is there something that you have information on the client themselves?
Not really. I only have on like what they buy. Yeah.
Okay. So all you have is basically client ID. So you don't know like the boy or girl or nothing, right?
Yeah.
Okay. So it's more like basket analysis, yeah. Because with basket analysis, it regardless of who bought it. Okay, gotcha. Okay, good.
Thank you.
Kap, let me speed along so that who's next? So you are, what's your name?
Radha.
Okay, Kap. Okay, Kap, who's next?
พิริยาค่ะ
Priya, Kap, go ahead.
โอเคค่ะ do you see my screen?
Yep.
Okay, so my project is like retail inventory management. I plan to develop a model that can classify types of products that are trending and find their common product pair. So the process that I will do is first I will find the data set of the online stores inventory, including price, quantity, order ID, product ID, and customer ID. So next, I will find the popular product by using the data from the data set. So I use count, sort, and select command in Mathematica to find the most popular product. Yes. And the last one, I will use market basket analysis to better understanding customer purchasing pattern and find the best product pair for them.
Again, you don't have information on the client themselves, right? So you can't really sort of like profile them.
Yeah.
Okay, gotcha.
So the purpose of this project is to find factors that can predict the popular products and their common product pair to help department stores and retailers to manage their inventory, increase their sales, and prevent shortages and overstocking. So let me open my data set. So this is my data set. It has order ID, which is tracking number, and product ID, shipping ID, which is tracking number. Customer
order
ID
number is unique per basket, right? One order number can have a few things, right? Yeah, I see. Yeah, I see.
Okay.
No?
Okay. So
No. Wait a minute. I'm not right. I'm not. Sorry. Is there one order ID for many products?
Yes. So it will write in like many sales. Like this is order 5446, and it will have like
okay. Gotcha. I see. Okay, good.
Okay. So this is my data set, and this is my Mathematica code. First, I just like count the product ID because I want to know like frequency of the item, and next I will sort them like to see the popular product, and I write the histograms to see that like most item appears in 100 to 200 and 300 to 400 times, and then I select just only like item that have frequency over 300, and then sort them to see like 5 most popular items in that store. Yeah, and I didn't do like I don't do it next, but I need to do like basket basket analysis.
Yep.
That's it.
Is this Keiko data or is this from your own company? Or?
Yes, it's Keiko data from like the US in 2020.
Okay, excellent, very good. And so you are Piriya, right? Piriya.
Yes,ค่ะ.
Okay, who's next?
ฮัลโหลครับได้ยินป่ะครับ
ได้ครับ
เดี๋ยวแชร์สกรีนแบบนึงนะครับเห็นป่ะครับ
Okay, go on. ครับ default. Good.
คือจะเป็นแบบทำเกี่ยวกับ education กับcredit card default นะครับ
Credit default. Okay, fine, good.
คือเดี๋ยวพอมันก็เป็น education ที่ classify เป็น graduate school university high school มันก็เป็น
A bit louder, sorry.
ฮัลโหลครับได้ยินป่ะครับ
Okay, good.
มันก็จะเป็น
So what is data set from? Where's the data set from?
Kaggle ครับ Kaggle.
Keiko. Okay, good.
So yeah, I got it here. See education, right?
Good.
And then over here it's like credit default payment. If they like default, it's 1 and 0. So if it's 1, it's default. If 0 is not default. Okay, so what I did was like, okay, here I set directory, right? And then I imported data here. And then I have to delete this first one because it's a text. Like drop it. And then I count the number of 0 and 1. When I count the 0 number of 1, right? And then I combine the sort data set, and then this is what I got. Like number 1 is grad school, right? And then number 2 is university, and 3 it's like if how do I say it? 3 is high school, and 4 is like others and other stuff. Well, yeah, because bank tends to loan the credit give credit card to like people with good credit, like graduate, like people who go to school and all that thing. So this is kind of less because they might not graduate in that thing. Okay, so what I got after that is I'm not done yet, but like this is what I got, right? And then I count the percentage and everything. Well, as you can see, the credit default people with like low education, all that stuff have like, yeah.
I think as a visualization, it's very good for you to single out factors, but don't get carried away with this, right? Because unless it's something that's lopsided, you can be dealing with something that's confounded. It's a bit like the suicide problem that your friends were talking about earlier. You look at the data and say, oh, young people kill themselves more, but it turns out, well, they kill themselves more because that country has nothing but young people. Okay, so this kind of thing is the same. So the influence of education in isolation, you can visualize it, and then you can give what's called stylized fact, but you cannot base your analysis on it, right? Your analysis has to be based on a machine learning or statistical model. Then you can qualify and say, all else being equal, people who have higher degrees tend to default less. You could say that in the end. But then, so don't get carried away with individual factor, but yeah, do explore it. Good. And you're a little bit lucky because most data set that has to do with default has very imbalanced data set, right? So maybe out of 100,000 clients, maybe only 5% defaulted. Because that's how business operates, right? If you default all the time, that's like a pawn shop. Yeah. So in a bank, you have much lower default rate. So your data is also going to be lopsided. So you have to deal with oversampling and whatnot. Make sure you pay attention to what I talked about last week in terms of in sample, out sample, and all that, right?
Yeah.
Validation. Okay. Good. Now this is good. And then you can again also, once you get to the model, you can also back visualize it with chat analysis and whatnot to say, oh, well, it turns out that yes, education matters, and the more educated, the less default, but it doesn't matter as much as say factor B or something like that. Okay?
Also, I can just try like maybe like I can try marriage and age too, and then just.
Oh yeah. Same comments for mine. I mean, no. If you were, I thought you were just visualizing education. If you're gonna throw everything else away, then everything I said to your friend, come find here. You have 10 columns, and to throw away 9 of them to play with one, that's silly. Don't. Okay. Don't do that. You're handicapping yourself unnecessarily. Okay. Use all the data. Good. Okay. Let the model tell you what does and does not matter. Okay. Throw them all in and have the model filter out the variable that doesn't make sense. Okay.
But
don't do it yourself. Okay. Okay. You Chotipat, right? Okay. Good. Very good. Okay. So next
is Anathon.
Okay. Anathon,ครับ You're up.
Can you see my screen, huh?
Good. Age group, abortion, year, percentage change. Oh.
So in this project, I would like to develop machine learning on performance data to investigate the trend of abortions over a time period in different states, and identify whether there were time series, characteristics, or other factors involved. And want to explore the pattern of how age affects the number of abortions over a time period, and also make a accurate model in prediction for the number of abortions in the next 5 years using linear regression. So
is this just one country? One?
Yes.
Give me a heading a little bit. Where is this data coming from?
Oh, it's from United States, like in every state.
Okay.
So this is the first data I'll be using.
So I would not just make it a time series model. Maybe there are some other things, right? That influence state differences. Now, in this example, you have one data set, which is good. but chances are the exploited variable would have to be something else. So you have to perhaps get another source of data that has to do with, say, tendency to be democratically run state or Republican stronghold. So that influences state. So you have to use some other data set, right? So the explanator, in other words, you can use this thing as a tab because you can identify data by different states. But once you identify the state, you can have all kinds of other variable that is associated with that state. Now that may not, obviously would not come from abortion data set, but it would come from economic data set. Okay. Now, maybe I didn't make this clear. You don't have to use one data source. In fact, in most of life, you cross-reference different data. You get abortion rate from this data set, but you get something like state unemployment from other data set. You get political leaning from other data set. You get demographic breakdown from other data set. Okay, it looks like if you are going to make, again, time series is very difficult to make significant. Okay, you need a lot of history, you need high frequency, you need lots and lots of dense data to do purely time series prediction. Chances are, if you have information like this that are factor, okay, factor, not across time, but across factor. Different county have different, whatever, economic, different composition, different, something like that. I think you should introduce. Don't jump to time series so quickly. In my experience, it rarely ever works, okay? There are times like financial time series because, you have price of a bond or stocks that's available every day, every minute. Then yeah, it does make sense to play with time series model. But if you're talking about like abortion rate, which is updated once a year, right? Or maybe once a month at best, to make it a pure time series model, I think it would be difficult. You probably would not get statistical significance. Okay? Now, you may, yeah, I'm not saying you won't, but I would not be as optimistic. I would try to link the data set to other state variable. Okay? Again, maybe at level of education, maybe the rate of high school dropout, maybe the amount that the government spend on healthcare, and again, the political leaning of Democrat versus Republican of individual state, that's also useful. Those are likely to be very important. After all, abortion is also one of those things where even though it's technically legal, different states can implement anti-abortion measures. That makes it more difficult, okay? So certainly a lot of political factors will make this different from one state to the next. Okay, try to do that. You still have time. Okay,ครับ
Okay,ค่ะ. Thank you,ค่ะ.
This is Panagon, yeah?
Panathon.
Panathon. Okay,ค่ะ. Okay, who we got the next?
Okay, the next we will skip to person because they have an emergency leave for today. So the next is Pawaran.
Pawaran, okay?
You here?
Hi, Ka. I'm here.
Hi, Ka.
Okay.
Let me share the screen. Okay, Ka. Can you see my screen?
Student performance. Okay.
Okay, Ka. So here's the student performance file from Kaggle, and there are like 1,000 rows and 8 columns. The attributes are gender, race, parental level of education, lunch, test preparation course, and also scores. And What I'm trying.
I like that you're beginning with data description. Okay, so that's good. Okay, some of your friends just jump right into the whatever solution or okay. So yeah, start with data description. Now, what you want to do with that, though?
So at first I just want to like do so this is like the homework that I turned in last time. So
Yep.
I was just trying to find like the correlation between each attributes. But then after I found out some of them, I feel like I want to also predict the average score of the test, the performance based on.
Very good. Okay. Are these high school or what?
I'm not sure. So there's like not there's no information about it, and also
because if you have like a lunch thing, I think I would imagine it's about public high school in America something with lunch or not lunch.
Yeah, and also like I don't know if I should get rid of the race or ethnicity column because it only tells like group A, B, C, but not the actual race.
They don't want to tell you. They mask it, but that doesn't mean that it doesn't matter.
Okay.
By the way, this is very important. I never told you this, but in banking applications, you can actually put in a lot of factors. Sometimes you are legally not allowed, okay? Because certain races have been disadvantaged, for example, have been bullied basically. So even though it is a good predictor, legally you are not allowed to use those variables. Okay, so this is happened. Like for example, in England, it used to be that one of the good credit predictor is the sex. So if you are female business owner, no banks will give you any money. Okay, no banks will give you any money if you're a female business owner. I think this is kind of like a cultural thing. In England, in Thailand, women own business. That's normal. But in England, women don't own business. The only time they own business is when their husband has gone to jail, probably for illegal behaviors or something like that. So for a while, putting in the sex of the business owner is a good predictor of credit risk in England. But this becomes discriminatory, so they disallow this. Okay, whereas in your case, you're not going to do any discrimination yourself, right? You're just trying to find out the factors, and it's math, right? In fact, you can match male and female as well as do sex A and sex B. Okay, so it's okay. It's okay. Use that. Don't throw that away.
Okay. So this is what I've been doing first. I just like see the shape and size and look at the description. So
you put in the data frame. Yeah. So A, B, C, D, E. Good. Yeah.
So so some of them are like object and some of them are integer. So I've done some visualizations and I've done some basic visualizations and also answered the questions that I've been asking. And I found that female students whose parents' highest education level in bachelor and master degree perform better than others.
I could have told you that female students are always better than male students.
So for males, it's like parents with master degree perform substantially better than other groups, but it's not true for bachelor degrees.
Gotcha.
Yes, and
it doesn't mean that boys are dumber, It just means that we tend to be distracted easily. That's my defense. Okay, go on.
Yeah, and for second one, I found that students who completed the preparation course perform better, but it's like the difference is not that big.
Now, again, since you seem to be doing pretty well, I would really try to put in the SHAP analysis, okay? Because now you're just comparing A and B, like different factors and whatnot. When you do the SHAP analysis, and in Python is even easier than Mathematica because it actually has somebody who's build the whole graph whatever. Okay, so use that to take into account, and so yeah, I certainly degree of the parents, the sex, but which one matters more quantitatively, right? You would really like to know that, right? So it's not just these three factors matter, but who matters more, in which direction. That's very good. Okay, so I will encourage you to actually, since you know some of your friends are struggling with just the data set right now, but you are okay with the data set, you've done the visualization, I would strongly encourage you to add CHAP plot and CHAP value analysis to it.
โอเคค่ะ
Good. Okay, ครับ who's next? We done or not?
Hello ค่ะ
Okay, the next is Tanya ครับ
ใครนะครับ
Tanya are you
ธัญ
here
ญา
Tanya
Hello
ธัญ
ค่ะ
ญา
hello okay Tanya
โอเคครับทายาเทียทายา
Taya
Okay, you're up.
โอเคค่ะ So this is the data set I chose. It displays customers' personal characters in relation to the price of their.
Good.
I chose this data because I am working on a school project that produces shampoo. So being able to visualize this data will help me define the personal characters of my project's target market.
Okay. Now I see that you have text, but you probably don't need NLP because I think these are just item name, right? You have like a finite set. So
Yes.
you can choose, yeah. So you ask I'm guessing you have like a survey question and you have like 5 choice for them to choose, right?
Yeah. Yes.
Okay, good. Okay, good. Right. Okay, so do a lot of visualization and trying to build some kind of model. A lot of your variables are categorical. Yeah, good.
Yeah. Okay.
In this case, I would say if your variable is doesn't have that many numerical values, but there's a lot of discrete choices, I would try decision tree based as a first shot as well. Okay, you can certainly represent this as a one hot variable and use neural network to predict, but definitely try decision tree type things. Okay, because you have a lot of discrete choices here. Yeah.
Okay. Thank you.
And Pinat, can you give the library of that visualization of decision tree that we saw yesterday? That's very good, I think. Okay, so share that with the students. So again, decision tree is a very nice, easy algorithm to interpret. It's not always powerful, but if you get a good performance prediction, it's good to use it to explain. Okay, Kap. So this is good. You're doing pretty well, I guess. Okay.
ขอบคุณค่ะ
So between now and next week, just for those of you who are struggling, what can I say? Just maybe get in touch with us a little bit or talk among yourself. It's okay for your friends to help you with coding and whatnot. That's okay. That's not cheating. Okay, you can help your friends. That's okay. But everybody has an individual project. It has to be a good project. It's okay to say, oh, can you help me with this? I'm having problem with turning Excel file into data set and stuff. That is okay. Okay, that's not considered cheating. That's completely, it's good. In fact, I would encourage those of you who have gone ahead and done really well in terms of data preparation to offer help to your friends. Okay, say, I got to hear anybody having problem with categorizing data, I can help. And I use this function, I created this function, anybody I can share with. Some of you like make a user-defined function, you can certainly share with your friends, right? Be generous. Okay, so look forward to being impressed by everyone next week. So next week, I'm just going to sit back and enjoy the show. Okay, Kap. Okay, so any questions, Kap?
Yes, I have.
Kap Hom.
So in the presentation, do we open the video and make it live?
Yeah. You can start with the video and then go on to the the PowerPoint, right? And the mind map. Okay. So if you start with the video, as we go along, if I think that I've seen enough, I may just say, okay, stop the video. I really want to ask you some questions or something like that. Okay. And then of course you're more than welcome to change the video and update the video later. So you have to submit the video link before next Tuesday, right? Monday. But the final video that would be graded on would be submitted along with your final written project. Okay, so you have, you can present on next Tuesday, and you have 2 more weeks to work on it, and maybe submit another video. That's fine. Okay.
The final video and the
final project will be like on the, I don't know. I think probably exam week. I'm not sure how the schedule work here. Okay, check with the course admin or something. Okay, Kap, any question? Okay, Kap, if you're keeping up, you're doing pretty good, and I wish you well. And I'll see you all. Kap,
I have a quick question about the paper, like the text report. Like, is there somewhere where I can get like something like an example from? Because like I read through the one that you wrote in the side notes, and I'm still a bit.
Oh, you know that I'm not making a requirement. If you can go to the last video, the YouTube video that I put in the notes, that one shows you how to actually write a proper paper on overleaf as a LaTeX file and then export as a PDF. If you can do that, that's like superb. But I think I'm not making the requirement. So you are allowed to use your own format. What do you think? Not หรือว่าเราทำเป็นเหมือนเป็นเทมเพลตให้เขาดีมันจะได้ง่ายๆหน่อยเอาไงดีก็ไม่เลวนะมันจะได้เหมือนกันหรือไง
I think maybe that is a good idea.
Okay.
Maybe we can do.
Okay, maybe we can do that. Okay, but the most professional looking thing, by the way, is that follow what the link that I show you. You actually go to Overleaf, and it's an online template. You can key in your text, and this converts in a beautiful LaTeX PDF. In fact, the paper that I gave an example to you guys, the COVID paper report, that and everything else, the paper that I did with your TA, that's also done on Overleaf. Okay. It's basically, it generates the very beautiful format that you can submit to publication. But I'm not making that requirement here, so that's why I didn't specify anything. But maybe we'll make a simple template format for everyone. นะเอาทำงั้นแล้วกันนะอาจจะได้น้องเขาจะได้ไม่ต้องกังวลนิดนึงที่ดีเดี๋ยวเขาไปหามาเดี๋ยวเขาก็เครียดเขาจะไปหาจากไหนแล้วจะมันดีไม่ดีอะไรเงี้ยโอเคครับโอเคครับ But certainly optional. If you can do like a professional looking LaTeX file, much better. Okay, so I'll see you guys on.
อาจารย์คะ Do we still have a final exam? No, right?
Same deal as midterm. Basically, mostly on concept. You're not going to do any calculation there. You won't be able to. Next year might be different. Next year you might be able to do some calculation on the exam. But right now we're using this exam class and we can't do much. Okay, so it's a limitation, but no problem. Okay, Ka.
Okay, Ka. Thank you, Ka.
Good luck, everyone. Keep safe and get your shot as soon as possible. And hopefully, we'll see you in real life at some point. Okay, good luck จ้ะ I'll see you guys on Tuesday สวัสดีครับ
Thank you ค่ะอาจารย์ stay safe นะคะ
Thank you ค่ะ
โอเคค่ะ